Day 2 of the Target 1 notes. Let's deal with these questions here. Any two 30, 60, 90 triangles are similar, true or false? Well, if we've got two triangles and each one of them is a 30, 60, 90, such as I've drawn there, and now another one, 30 and 60 and 90. This triangle might be a lot larger, the segments might be longer, but hey, I'm guaranteed to have not just two pairs of congruent angles, but three, and all I need is two. If I've got two pairs of congruent angles, for sure the triangles have to be similar. What about two squares? Would two squares be similar? We haven't talked much about squares, but think of it this way. Does this square look like an enlargement of this square in a photocopier or on a computer? I mean, if you enlarged a square, it would still look square. All the angles would still be right angles, right? And wouldn't all the segments match up? If this is twice as long as this, wouldn't this have to be twice as long as that? And every side in this square would have to be twice as long as every side in the original square? Sure, squares would definitely be similar to each other. What about two rectangles? Not necessarily. Look, a square is a rectangle to begin with. What if my other rectangle looked like that? Here's two rectangles. They're not similar to each other. Yeah, I've got right angles all over the place here still. Okay, but squares are more complicated figures than triangles. In triangles, if I've got two congruent angles, that's enough. But not with larger, more complicated figures. Clearly that does not look like an enlargement of this, or vice versa. How about two right triangles are similar? Well, here's one right triangle. Here's another right triangle. I got a right angle there and a right angle there. No guarantee that any other pairs of angles are going to be congruent. That definitely does not look like a computer enlargement of this. This looks like it's been stretched wide, but it hasn't gotten any taller. Right triangles do not have to be similar to each other. How about isosceles triangles? Nope, not isosceles triangles. I can draw one isosceles triangle like this, and I could draw another one like that. Those don't look similar to each other. I mean, look at those angles, how different they are. That's false. Two equilateral triangles, how about equilateral triangles? There's a small one, there's a big one. Similar to each other? Yeah, you bet. Don't we know what all the angle sizes are in equilateral triangles? They're all 60 all the time, right? So we've got more than enough pairs of congruent angles to say that these triangles would have to be similar.